Hello, and welcome to this OpenTopography tutorial. Today I will be discussing how to extract and download ground classified points using the OpenTopography interface. These points can be particularly useful for looking at bare earth studies, where we may not want to have vegetation, as well as for generating digital terrain models, which are raster data sets with the vegetation removed. So the first thing you want to do is go to opentopography.org. And as always, we recommend that you make an account, although you can do some processing on OpenTopography without an account. The next thing that you'll want to do is click on Data. So that will then take us to this page where the default view is all of the OpenTopography data sets that are available from the United States. And so first today, we're going to be looking at an example along the Kaibab Plateau of northern Arizona. So you want to go here and say, select a region. We'll put a box over the area of interest. And then that automatically scrolls us down where we can see the available data sets. And in particular, we can see there is a formerly OpenTopography hosted data set called Mapping the Kaibab Plateau, Arizona. And this data is open to everyone. And there is also within the point cloud USGS 3DEP, there is this Arizona North Kaibab National Forest. And this data set is in our academic and OT plus category. And this means that US academics can access it, non-US academics can access it with an application, and others can access it via the premium subscriptions button here. And so we'll be looking at getting the point cloud dataset. So that then brings us to this window. And we can then look to process this dataset. So to select the ground-only points, you'll want to go here in this first box to where it says choose return classification and then select the ground. You can see here that we have roughly 63 million points, which will be processed. By default, we'll be generating a digital elevation model using the tinning method. And I like to recommend to generate a 3D point cloud visualization, as this is a really helpful way to visualize the point cloud dataset, which includes looking for different errors, as well as confirming that we in fact do just have ground classified points. We'll say go, and then we can run. And now here are the results for a different but similar data set over the Kaibab Plateau of northern Arizona. And we can see here that we've generated a digital terrain model. So again, this is a raster data set with the vegetation removed, so we can really see the shape of the topography. And then we can also click on this View 3D Point Cloud in the browser. So here it is. We can zoom around, rotate, and it does appear that there are no trees or other vegetation, which again was the point of selecting ground points only. We can also come here to display attribute, for example, and look at classification. And we see that there is only one classification, which is shown by this brown, which reflects the ground classified points. All right, so now I'm going to show you an example in somewhere else. So we're going to look in New Zealand. We're going to look at Auckland. So again, we're going to go here, select a region, and then put a box over Auckland. We can come down here. We see that there are these 3 data sets located over that box in Auckland, and they are all open data. So we'll be looking at this first one collected in 2024. So we'll say get point cloud data. And again, here we're seeing Auckland. And in this first window, we have again the option of choosing return classification. And here there's 3 different options that we can see at this level. So we can select all points, standard classifications, or advanced classifications. Now, if you're interested in extracting just the ground classified points, then you can come here and first click standard classifications, where you have the option of choosing any or all of these point classifications. So we can decide to process just the ground points. We do also have the option of advanced classifications, where we can decide to extract any one or set of the classifications within the data set. But for this example, let's select just the ground classified points, which we can do via the standard classifications button. We can again calculate a TIN, and then let's do this generate 3D point cloud visualization again. So we'll click the button, and then we'll say submit. So this is now being processed at the San Diego Supercomputer Center. And here are the results from a similar job in Auckland. And in this case, I did not select to make a hillshade, so we cannot see the hillshade, but we can still click the View 3D Point Cloud in browser. And so here we have that area with just the ground classified points. And so we have buildings as well as vegetation removed. And these holes that you see in the data set very likely are buildings. And if you would like to download the point cloud dataset, you can click this button to download the LAZ file.